Lesson 20.2, Task 3. Subtract two models. All right, subtracting functions can help you compare two quantities by telling you when one of the quantities is greater than or less than the other quantity and by how much. A laboratory has cultures of two types of bacteria, type A and type B. Information about the type A bacteria is shown in the photo. The initial population of type B bacteria is 1,500, and the population decreases by 75 bacteria per day. All right, the initial population of type A is 100, and the population grows by 25% per day. All right, so we're given two different scenarios here, type A and type B bacteria. All right, so it says write equations that give the following quantities as functions of time: the population of type A bacteria, the population of type B bacteria, and the difference between the type B and the type A populations. Then evaluate the difference between functions at times 4 days and 11 days and interpret the results. All right, so to write an equation for the type A bacteria population as a function of time, we're going to assign each one a name. So this is function notation. So it says let P of T, and this is for bacteria A, so P sub A of T. That's going to equal the population of type A bacteria at time T in days. So it says because the population increases by a fixed percent per day, it can be modeled by an exponential growth function. The initial population is 100, and the growth rate as a decimal is 0.25. All right, so if you remember, exponential growth function, y equals ab to the t power, and we can write the b, this is our growth or decay factor, y equals a times 1 plus r for growth, and 1 minus r, r's our rate, to the time, or raised to the t power, which equals time. So those are three different things that all represent pretty much the same thing. They're all growth or decay. This is the general formula, ab to the x or the t power in this case. And when it's raised to a variable here, that means this is exponential growth or decay. When it's when your b is greater than 1, so 1 plus r, so when this is greater than 1, it's exponential growth. When you have 1 minus r, it's exponential decay. All right, so they're going to write the equation. It says the initial population is 100, and the growth rate is 25 or 0.25, so 25%. So we've got P sub A of T equals 100, that's our initial value, times 1 plus 25. You can see all they did was plug the 0.25 in here, and they plugged 100 in for A. All right, so that gives us P sub A of T equals 100 times 1.25 raised to the t power. Because r is greater than 1, we know this is exponential growth. All right, so it says write a function for type B bacteria as a function of time. So it says let P sub B of T equal the population of type B bacteria at time T. So you can see these are named the same except the A and the B. That distinguishes which type of bacteria it is. So it says because the population decreases by a fixed number of bacteria per day, it can be modeled by a linear function. So the initial population is 1,500, and the rate of decrease is 75 bacteria per day. All right, so remember a linear function, y equals mx plus b, where m is our slope, that's what it changes each day, rise over run, and this is our y-intercept, okay? So slope, and this is review as well. This is actually 8th grade standard, but we did review it earlier this semester. All right, so 1500 initial value, that's our y-intercept, so it would go in for B, and then 75 bacteria per day. So because it's a decrease, it's going to be minus 75 bacteria per day. So if we wrote it in slope-intercept form, it would be y equals minus 75t plus 1500. All right, so this is still slope-intercept form. This just has the commutative property has switched the order of the numbers there. All right, so it says write an equation for the difference between type B and type A populations. Let D of T equal the difference between type B and type A. All right, so D of T equals P sub B of T minus P sub A of T. All right, so if we do the first one, this was B, so we're going to do 1500 minus 75t, and then we're going to subtract the 100 times 1.25 to the t power. So we just subtract the A bacteria. All right, so it says complete the statements regarding D of T. The right side of the function, D of T equals 1500 minus 75t minus 100 times 1.25 raised to the t power. So it has three unlike terms. So there's one term, two terms, and three terms. These do not have like variables, so they are considered unlike terms. Therefore, the function cannot be simplified, which means that's in simplest form right there. That's as far as you can go with that function. All right, so it says evaluate D of T when T is 4 and T is 11 and interpret the results. So all we have to do is plug in 4. So we're going to do these one at a time. So D of 4, and anywhere where we see a T, we're going to substitute a 4. So we're going to have 1500 minus 75 times 4 minus 100 times 1.25 raised to the 4 power. All right, when you type that in, make sure you do order of operations. If you do it by hand, you're going to get approximately 956. Let's see if I type that in, if that works out exactly that way without, see if it'll do order of operations for us. So we got 1500 minus 75 times 4, then minus 100 times 1.25 raised to the 4th power. All right. That says about 1235. So see how if you just try to type that all in as one big expression, it's not going to do order of operations. So what you need to do is the exponents first, then multiply, and then combine the other stuff. So you would have to start with 1.25 raised to the 4th power, and then times that by negative 100. And then you're going to add the 1500 and then add that to negative 75 times 4. And then when you do the order of operations, you see that it will come out to be this approximate answer. So just be aware, if you try to type that in straight how it looks, you may think, oh, my calculator is going to give me the wrong answer. But because this has exponents and it has multiplication and addition and subtraction, your calculator is not going to do order of operations. So you are going to have to do that one step at a time. So remember, always exponents, then multiply, then add or subtract when you're doing order of operations. All right, so D of 11. So we're going to find the same thing, except this time we're going to use the same formula, except this time we're going to use 11 for every place there was a t. Again, order of operations, start with your exponents, multiply, then add in the rest. You're going to get approximately negative 489. What does a negative value of d of t mean? When t equals 11. Complete the statement. Well, it means that the type A population is greater than the type B population on day 11, because that's what we evaluated it for, is day 11. All right, so in conclusion, after 4 days, there are about 956 more type B bacteria than type A bacteria. After 11 days, there are about 489 fewer, because it was negative, 489 fewer type B bacteria than type A bacteria. So you can see on day 4, there's still more. And then by day 11, it has reversed. All right, so that's all for task 3. If you have any questions, let me know.